So this is a really important point that I've been pointing out, is that powers and roots are incompatible with addition and subtraction. They do not mix together. Okay, so we cannot do any powers or roots until we group it into multiplication or put it into factors. So here we have a plus. Okay, we cannot square root this and we cannot square root this. It does not work. Okay, it's just not compatible. In order to be able to do any kind of radical algebra, we have to be able to express this with multiplication. And expressing something with multiplication is factoring it and showing it as times. So we have to find a greatest common factor. So the greatest common factor between 8 and 4 is going to be 4. The greatest common factor between a squared and a cubed is a squared. That's a factor. That's a times piece. Now that it's times, I can do some radical algebra to it. So I'm left with 2a plus 1. We divide to get the 2a, we divide to get the 1. So here we now have multiplication. Okay, we still cannot do any square rooting across that plus, but here we have a times piece. We can actually apply radical algebra to this. So we can square root this now. Before we couldn't square root here. We cannot square root this because of that plus. Okay, it's connected with plus, and again, radicals cannot be done with pluses and minuses. This 4a squared is now a times. Now we can apply radical algebra. I can now square root that into 2a, and I'm left with 2a plus 1. Okay, and there's nothing I can do there. So again, it's important to recognize that this 4a squared is a factor. It's connected with times. This 4a squared is not a factor. It's connected with plus. We cannot square root here, but we can square root here. So here we're looking for perfect cubes. Again, we cannot cube root when there is pluses and minuses. So what has to happen is we need to factor. So I'm going to factor a greatest common factor out. Okay, between 27 and 16, they do not share any common factors. Between b4 and a cubed, they do not share any common factors. This is it. We have to leave it as 27b4 16a cubed. Okay, we cannot cube root this piece here or take the perfect cube root here. This is a perfect cube because it's connected with add and subtract. It does not work. There's never any circumstance where we can cube root that and that separately. So here we can, when we introduce the perfect cube inside, so we end up with 2 cubed, a cubed, b cubed. So going from outside to inside, we're going to apply the cube to it. But when we do that, we can only introduce it as multiplication. Well, if it's multiplication, it's got to multiply that everything inside as a factor. So we need to group the inside, the plus and minus on the inside together and make it a factor. Once I've done that, I can leave it like that, or I can take that factor and actually multiply it into the brackets inside the cube root. So I end up with cube root 16a cubed b cubed minus 8 times 7 is 56 a4 b cubed. Okay, and these are equivalent expressions. We've taken the perfect cube factor, okay, the 8a cubed b cubed, we factored it first before we were allowed to take it outside. So this is important that we don't multiply these things in like this. Okay, although there is a plus, we have to first of all cube it first. So we have to do 2 cubed first, and then we can apply the multiplication. Once we have connected the multiplication part inside the cube root, we can now apply the distribution here. Okay, so the outside 2 must be inside 2 cubed. Now that becomes, we can do this. We can then do 8 times 5 is 40. 8 times a is plus 8a. So whenever we see these plus minus pieces, we just have to be extremely careful in that we have to treat them as factors. Okay, so going from outside to inside, I'm going to cube, and then I have to treat the plus and minus parts now as factors. So I have to group them. So outside becomes inside cubed. I can simplify this, 27b cubed. Okay, and again, it's the idea that this is not compatible with, the roots are not compatible here. This is all connected by multiplication, so we have to group this into a multiplication. Now, if I want to apply the multiplication, I need to distribute across that minus. Okay, so we do your distribution, 27 times 3, b cubed times b, minus, and then I do my distribution to across the minus to the 8. 27 times 8. 27 times 8, what's that going to be? 216, I think it is. Let me just double check that. 20 times 8 is 160. 7 times 8 is 56. 160 plus 56 is 216. I end up with an a here. B cubed times b is b4. Okay, and these are not like terms because they do not share all the common variables and powers. So lastly here we can go from outside. The index is 4, so I have to power everything up by power 4. Okay, so there's my outside showing up inside. Okay, I can then apply that power. What the really important part is that you now, because we're introducing times, we have to now group this as times, and grouping it as a times by putting brackets around it. Okay, and then now if we want, we can leave it like that, but we can also distribute. Okay, in fact, I'm just going to leave it like that because sometimes it's good enough. Sometimes we want to keep things in factored form. If we're going to do that, we probably should factor out the extra x. So I'm going to leave this answer in factored form. I'm going to take the extra x out. So I'm going to end up with x5, y4, and then this becomes, if I divide, I get 1. And I just have the 1x left in here. So I've taken an x out of here and here. That's my common factor. And I can express that as times on the outside.